Now, how's things, guys? So today we're going to cover how to perform a crosswind study in Ansys Fluent. We look at how to set up your domain, how to set up your boundary conditions, how to get your mesh right for the amount of cells you want, and then what to put into the solver to solve the crosswind study. So what we look at first is some of the equations that we'll be using and a general look at what our domain will look like. So as you can see here, these are the six coefficients that we'll be calculating. We'll be getting the drag, lift, and side force coefficient, and also the moment coefficients, which are the roll, pitch, and yaw moment. The yaw moment being the most important when it comes to stability. So what we'll have is we'll have our usual direct oncoming flow, which I'm having set at about 80 kilometers per hour, 22 meters per second. And then I'm going to have a crosswind of about 5 meters per second coming in from the side, 90 degrees to that flow, which will give a magnitude velocity of this. And then that'll also work out then as a yaw angle for the flow of 12.8 degrees. And they come from those two equations there. So it's all fairly straightforward stuff. Now, what's really important is you're going to be modeling your domain with two inlets and two outlets. Okay, there's multiple ways you can do this, but that's a nice way to look at it. And then you're going to have a body of influence behind your vehicle that you would have maybe originally had for your direct yaw equals zero flow, and then also a body of influence for kind of the leeward side. So just so you're aware of some of the terms as well, the windward side is where the flow hits, and the leeward side is where it's kind of in the wake of the crosswind. In these formulas here, we'll just talk about some stuff here. A being the reference area, usually your frontal projected area, and L is a reference length that's needed for the moment coefficients. And depending on what convention you want to use, this is up to you. You could just set that to be 1 meter. Some people set it to be the length of their vehicle, and then for say like a truck or something, people might set it to the square root of A. So you can read up on that and choose whichever one you want. It doesn't matter. Then the reference velocity. So that'll be it's very important that you set that to the same reference velocity as you would for a yaw equals zero flow, so direct flow. So that would have been 22 meters per second for me. Um, I'm going to keep that as 22 meters per second even for the crosswind study. Even though you might say, okay, there's a new Vmag here, but keeping the same reference velocity in zero yaw and then yawed flow like this is important because then I can kind of directly compare how the drag changed, without there being a different V on the bottom. So this thing down here is always constant. Grant. So this is what you're hoping to have in your domain. You'll see your bodies of influences. So I'll just go through some of the names on things here. So here I have my crosswind BOI, and that's what I call a medfine one, and this here is a coarse one. Then this is the far wake, and that's a medfine one, and this is a coarse one. And you'll see some of the cell sizings I put on them. And in there I have three different bodies of influences: a coarse, a medfine, and a fine. The fine being the closest to the vehicle, and the coarse one being the one you can see there. So yeah, so just some stuff then on this. So the length of my vehicle is about, it's close to 10 meters. The width being about this, and the height that. So what I set my domain to be is 4L in front, 12L behind. And then you can see here I'm going for a sort of ratio of 3:1 as well. 18W in the leeward side, and the windward side 6W. Okay, and then I also set my domain to be of 5H height, sort of out of the page. Grant, so that's that covered, and that's what I'm modeling here, a flatbed trailer in a van. So that's what it looks like in the domain. So it's quite small, so there's quite a lot of area and space. Probably doesn't need to be this big. You can mess around with it yourself and choose whichever one suits you and what your computer is capable of in terms of cells and that. So there you go. I also have some bodies of influence around my wheels, my front wheels, back wheels, and trailer wheels. And then I have some bodies of influence around my mirrors. And then that's what things look like with all the bodies of influences removed. So keep going through stuff. And here is some general stuff on what I set my mesh to be. Now you can experiment with these depending on what suits you. I have these set in a certain way in that domain, in a certain way that I'm going to get about somewhere between about 60 million-ish cells, which is what I want. But I could change them and tweak them to get maybe if I wanted an 80 or 100 million mesh. And then you can also tweak where you want to put the extra refinement, whether you want to put it in your inflation layer or in your volume mesh, depending. Okay, so that's something that'll take some experiment. You might literally spend maybe 5, 6 hours, meshing stuff up, depending how quick your computer is, to try and work out what actually suits you. But the main thing is going into a crosswind study, know that, okay, I want to have 30 million cells. So what I do is start off with all of these really high and then start refining them smaller and smaller and seeing what that does to the cell count. Grand. Okay. That's A1. So we'll go over now to space claim to start modeling up our domain. Okay, so we're over here now in space claim, and what we're looking at here. So what I'm starting from is a simulation that I would have ran for a yaw equals 0 flow, just the direct 22 meters per second coming onwards. And I'm going to take this and adapt this to suit my crosswind study. The reason I've done that is because, as you can see, a lot of my name selections are already in there. Like stuff like the mirror and that. So it saves me starting from scratch. But if you haven't done this, but you probably should have, because how are you going to compare your crosswind study to directly oncoming flow if you haven't this already done? So I'd recommend just duplicating this and in Workbench and adjusting it for a crosswind. Grand. Okay, so starting from this point here, you're going to make sure that you have your symmetry plane defined quite well. So I have a few different planes there. This is my symmetry plane. Good to name it up. So I'll rename that symmetry, and I'll keep that turned on there for this first initial piece. So what we're going to do is we're going to mirror everything over, and I also have my initial bodies of influence here and there. So I'm going to turn them on because I'm going to mirror them as well. Okay, so you want to come up here to design, and then you want to click mirror, and you want to select your mirror plane, which will be this, and then bodies to be mirrored. Now you want to turn off here create mirror relationships, and you can keep on merge mirrored objects. So I just click that, and that's that mirrored there. I can then also want to do something similar for the bodies of influence. So I'll just zoom in here so this looks reasonable. So you see how they're being generated on the other side. Have him, and then he'll merge with him. Then that's the far med fine, and then also there that's the far course. And then these are the inner ones. So that's near fine, and then that's sorry, that one was near med fine, and this one here is near fine. So that's everything. That's everyone mirrored up there. So yeah, let me just go through them. Okay. Turn off the enclosure just to have a look to make sure everything's good. So I can see there my wheels. That's my mirror. That's the course. They're the wake ones. That's the med fine. That's the fine. And then you can see these are the wheels on the other side. Okay, so I'm missing one there. I'm missing the mirror on the other side. So we'll just create that one there. So you go mirror, select the mirror plane, and then the object like that, and make sure create mirror relationships turned off. Grand. Okay, so that's everything. Now the next part is pretty annoying. What you'd have expected is that when you have all that stuff mirrored, that your name selections will also have mirrored. So this is possibly the most time-consuming process of creating a crosswind study from the starting point that we started with here. So as you'll see, like if I look here at my bumper bulk, you see that it hasn't perfectly mirrored. The bumper bulk would have been the right side there, but it hasn't mirrored over on the left perfectly. So I'll have to fix that and highlight that myself. Faces like this where they're a continuous face, they'll have continued over into the name selection, but a majority of it wouldn't. But before we do that, we'll rename some things here. So as you know, we're going to change this inlet here. That's going to stay as an inlet. We'll call that one inlet main. Right, now we can hide that. So that's known as the sky, so I'm going to delete that for a minute because I don't want it named. And this is going to be inlet side. Okay, and you can move now. Another thing, because we're messing around with this here, we're going to bring all this stuff down so that way I can see this as big as possible, and bring this stuff up to the top so you can clearly see it, that you have your Main there, your inlet side. Okay, and then the ground is fine. Okay, so that's okay. So this guy now will become known as sky, and sky will go down as a symmetry plane because it's a decent distance away. So I'll adjust the length and height and domain in that uh, after I do the inside sort of name selections. Grand. That's the outlet, so we'll call that one outlet main. Outlet main. Hide that. And then, did we hide sky? No, we didn't. And then the last one here, so we'll call that one outlet side. And that's everything. Okay, so we'll hide that. So there are your three, there are your 6 outer faces done. And keep them together up there so you can just go through to make sure they're all good. Ground sky, outlet main, outlet side. All good. Now, no need to change the BOIs. We'll change them when we move into design modeler. Now, so I'll go through some of these here that are in my list. That's okay. I'll save the project. Actually, good to save the project as you move along because you're working from a workbench project. So that's saved there. So you'll see here now, what I'll have first of all is my wheel radii. So I'll move that up so I'm in following a good order here. So skip over my BOIs. There's my wheel radii. You see it's only the wheel radii that are on the right here. So what I'm going to do is I'm going to keep those highlighted. I haven't clicked off it. If I click off something, that goes away. So I'll just click the wheel radii here. Then I'll hold the control button and then I'll highlight these. So making sure not to click anywhere else because it'll deselect everything that's highlighted. Good stuff. Now click create name selection, just call it 2. Then you want to go up here, get wheel radii, copy it, its name. So you need to be very sharp doing this, be very alert. So you want to delete it now. Come down to 2 and paste in the name. And then that's perfectly done there. And then you can move it back up so you keep nice order. And then hide that. So I'll do it again. So you see that's the wheel radii is now perfectly named up. And I gotta do the same thing over here with like my F wheel. So it's pretty annoying that you have to do all this by hand. You'd expect that Space Claim would give you an option when you're mirroring. Do you want to mirror name selections as well? But sadly it doesn't. So you have to spend time doing all this. So you do need to be quite alert. There's some simple steps, but depending on how complicated your geometry is, it could be quite tricky. So particularly the deleting it at the right time, copying and pasting at the right time, stuff like that. It's very important. Grand. So I'll just do I'll do the back wheel here, and then I'll skip forward because you have a fair idea of what I'm doing. And again, too, when you finish stuff, be sure to move things up so that you go through in a nice order. So I've already done wheel radii, I've done F wheel, now I'm going to do B wheel. Great, so I'll pause it there and we'll skip forward. Now, hey guys, we're back. So that's all done there. So you can see that like from my F wheel all the way back to stuff like van rear and trailer front bulk, they're all done. So you know it's a tricky process, and there's a cool thing you can do up here just to make sure you haven't named anything twice. You go into the name selections and you right click it and click detect overlapping sections. And so like if you named face in 2 name selections, it'll warn you of it. That's something you don't want to happen because when you go into Fluent, if a face has it's part of 2 name selections, it gets pulled apart into a new name selection and it's got a new name and stuff. So it's just something to try and avoid if you can. That detect can help do it. Now, so that's done. What we're going to do next is we're going to change the domain size, and then we'll add in the new body of influence for the crosswind. So we'll show the faces there, the outer faces. And so yeah. Now what I'm going to do, as per what we know, based on what was in that presentation, in terms of like 6W here, 18W back there, and 4L here and 12L behind, and then 5H height. So I'm going to adjust things now, and we'll have a look at that. So what I'll be doing, just for an example here, you just grab the face that you want to change. You can, no need to click no merge. So you want to pull the face, pull it like that, press the space bar, and I know the height of my domain to be 5H, and H standing for 1900, so I'll just add 1900 to it because I knew it was already 4H above the van. So yeah, when I say 5H, I mean 5H above the van. So in total, the domain is like 6H in height, so 5H above the van. And it was originally 4H for the directly oncoming flow, so I just added an extra H to it there. The front and back are fine, they're both 4L and 12L. So in terms of the width at the minute will be 4W this way, so I want to add on another 2 Ws, and W being 2250, so I'll grab that, press spacebar and go 2250 times 2. So now that's 6W that way. This here is 4W this way, and that needs to go up to 18W. So pull that, click space. So to go from 4 up to 18, we're going to have to add on 14 Ws. So 14 times 2250, like it that. And that looks reasonable now. So you can see there's plenty of area here for the leeward side. And what you could do as well too, you could, maybe draw a line from there to there with an angle of 12.8 degrees, whatever angle your flow is at, to make sure you're happy with the shape of your domain. Grand. Click out of that. Okay, so I'll just save this. Right, so what we're going to do, we'll just look down on top here. We'll have a look at the body of influences. So they're just the wheels in the mirror. Now these here are my my sort of far wake domains, so they're fine. They're not doing anything wrong. And that's kind of my large near version. So I can maybe leave. I'll turn that one off, and I'll turn this one on. Where is it? There it is. Okay, so I'm going creating a new body of influence. So what I'll do is I'll hide these faces again. That's the 6 of them, yeah. So hide. And now I'm going to create a sketch. So I'll come down maybe the bottom of this face here. Yep. And then look here. So what I'm going to do is I'll draw it from there to there. Now I'll give you the dimensions I have on this. Yes, does that sometimes. Depends on what face I clicked. So let me Control Z that. And then I'll just go back to thing there like that. So we'll try this again. So I'll try and draw on that face there. Look down from on top. Then I just want to draw a rectangle there. So it glitches out like that sometimes. So what I'll do is I'll just I'll try it once more. Go back to 3D mode, and I'll go back to structure here. Turn off that plane. I'll try it again, and I'll draw on the plane. Okay, so that one worked. So best thing to do would be to create maybe a new plane if you don't already have one on the original bodies, because that's the bottom of my domain, and then you can work around that glitch if it happens to you. So what I have here in terms of the dimensions on this, I have it 3000 in front of the kind of medium body of influence. So you can size this however you want. This is just how I like to size it. 3000 that way. Now, in general, I'll have this going back 3.5 times my length. Okay. And then height-wise, then I'll have this at 6W. So 6 times 2250. like that. Yeah, nothing more to say on that. I think that's everything grand. So I'll return to 3D mode. I'll grab that face. Very important to click no merge. Now I'm going to have this then, in terms of its height, I'll have it 2h. So that's 2 times 1900, like so. And you can see then that lines up quite well with the other body of influence that goes outside him there. See? And there's a bit of overlap there, so don't worry about that. Whichever one is finer will win out, so I don't mind them overlapping a little bit like that. It's grand. Okay, so that's that, spaced out like that. And what I like to do then is split that new crosswind body of influence into two. So I click these two faces, click plane. So there's a mid plane there, and then I go split body, click that body, then click the new plane, and then press escape because you don't want to delete any of those bodies. Okay, and then in a similar way, I want to split this body here. So I'm going to split this in half. So to do that, I'll hide this body here, the far one. There it is. Like that. The plane in the middle. Now I'll give this a touch more. So I'll move this, might move this one back here, maybe 5,000. I'll give it a touch more, 10,000. Yeah, okay. 8,000. And then, so that's just, you can size it however you want. Split body, that, click escape. Then I'll turn this body I switched off back on. There. And then I'll combine these two together. So triple click that, control, triple click that, and click combine. And that's everything set up. There's nothing more to do here in terms of setting up the domain. So you can just check that everything, so that we understand. I'll just save that while I walk you through it. This here is known as BOI far course. This is BOI far medfine. That's BOI crosswind medfine, and that's BOI crosswind course. And then in here around the vehicle, we'll have the BOI near course, BOI near medfine, and then inside at the very close is BOI near fine. And then you'd have your usual wheels and mirror ones. But other than that, now that's everything there. So you can just click save project then, and then what we'll do, I'll X out of this, letting that save. So what we'll do is we'll duplicate that. Now 1 second, I'll have to fix this. This happens sometimes. Okay, we're back. So the reason that that error happens is because I clicked save project and I X'd out of the space claim before it had time to save. So I'll duplicate this now. So this is a workaround that I use. I don't let space claim go directly into Fluent. I always bring it into design modeler for a little bit. So I call that DM underscore to say it's the design modeler version. So we let that load up. So all I'm going to do in here is I'm going to give the body of influences specific names. I'm going to make sure that everything is a fluid. So load that in there, click generate. It can take a second or two depending on how big your domain is and how many sort of curved faces and that are in it. Usually doesn't take more than about 10 seconds. So 100% cool. Right, so highlight all these faces, holding control to highlight multiple faces. Change them all to fluid. Now this is the naming convention I have for these guys. So that one there I call BOI1. That there I call BOI2. He then is BOI3. That's BOI mirror. That's BOI near course. That's one back there is Boi far course. That's Boi near Medfine. And that's Boi near Fine. This here then, that's Boi 1-2, the 2 referring to it being the other side. That's Boi 2-2. And then this is Boi 3-2. Then that's Boi mirror 2. That's Boi Crosswind CW, and that's the course version. That's Boi Crosswind Medfine. And then the final one then is Boi far Medfine. And that's everyone. Near Medfine, yep. So 16 of them. So I usually click generate once more and then I press save. And same again, just give it a bit of time for the project to save before you X out of it if it's a big project. So I X out of that then, and that's everything. So what I'm going to do now, I'll bring this over into Fluent and then we'll show you how to mesh it up. Now, so we're all loaded up into Fluent here. So what I done is took that Crosswind domain thing I made in Space Claim and Design Modeler and brought it in here to a Fluent block, and that's a duplicate of the Fluent block that I would have had for when I done this FBT1 triple axle in direct flow, yaw angle equals 0 flow. So a duplicate of that. Right, so we're in the Fluent mesher. What I'm going to do is import that geometry. So that'll take a second. So you see maybe the original mesh there. If you seen it, it was just like a one kind of long section, which was for the direct angle flow, and you'll see this one now is the crosswind one. So you know you've read it incorrectly. Right. So my BOI wheels, as we know, there's 6 of them now, not 3 of them. So that's the 6 guys there, and there's the 12mm as you've seen in the PowerPoint. The mirror, we know there's 2 mirrors now. Near fine, there's just one of them, and that I have size not at 22, but at I think 24 I had it down as, just make sure. 24, yeah, for near fine. Near med then, I think 32. Yep. Near course then, that's 50. And there's one of them. Now far med, so they're my med fine. Now this is very cool, so you can just put wildcards either side of Medfine there and it'll search them out. So there's 2 called Medfine, and they're not sized at 45. They're sized at 60. Okay. They're sized at 60, and then far course, there's not one of them. So if I search course, I'll get the 2 guys here. So I want far course and crosswind course there. So they're not 72, they're 70. So I'll update that. So this is a very cool way of, I'll just update the rest of the stuff. There's 15 faces, not with a bulk size of 8, but a bulk size of 10. And then I just have stuff for my wheel surrounds, my wheels, mirror. You can pause the video if you want to add any of these sections. There's 3 fine faces, the wheel radii, I size at that. Now before I click generate the surface mesh, you can go back and click that button there to have a look and make sure everything's in right. There's my wheels, my mirrors, near fine, near med, near course, while you're checking as well that your sizings are incorrect. Near course, yep, 50mm. Far med then, them guys are 60mm. Them guys are 60mm, yeah. And then the course faces, those guys are 70mm. Yep. And then my 10mm bug faces are there, as you can see. So a very cool way to look at your stuff. There's my wheels. Grand. So what I'll do is now I'll click generate here on the surface mesh. So this is going to take maybe about 15-20 minutes, and then we'll take it up there from describe geometry once this is done. So that's my surface mesh generate. Okay, right, back in a bit. Okay, so we're back after that's done there. It took about 20 minutes, as you can see. Got about 5.5 million face count. It's quite a bit. So yeah, hopefully it doesn't come out too big when I do the volume mesh. Okay, so what you want to do, come down here, describe your geometry, and then make sure that it should be okay. They'll be read in as velocity inlets because they've got the word inlet in their name. Same here with the word outlet, they'll be put down as pressure outlets. I already have sky before as a symmetry, and everything else should be a wall. Ooh, so click update there. Boundary layers, then yeah, you want to have your last ratio, and then you can save yourself some cells too from having this, rather than growing on only walls, grow it on selected labels, and select for it to grow on everything except for the ground, inlet main, inlet side, the outlet main, outlet side, and the sky. So those 6 faces don't need any boundary layers. So the only one that we'd be really ruling out there was the ground. You don't need the boundary, the inflation layers on the ground, because the ground is moving, it's moving relative to the flow. It's, yeah, with the relative velocity of 0 to the flow. So the flow moves at 22 meters per second. Imagine in a directly oncoming one, and then the ground is moving at 22. So there's no need for that fine sort of boundary layer to grow, inflation layer to grow on the ground. You just want it on your vehicle surfaces, which are stationary. Sound. So you can update that. It'll save a few million cells from growing on all walls. Okay, so update that. And then that's my volume mesh. So I'm going to have a minimum cell of 1 and a max cell of 256. So this will take a while. And then after that, then I'll also have an improve volume mesh task, which will be to try and improve things to 0.15 cell quality. Okay, so I'll usually click improve volume, so it'll update this one beforehand. So that'll take about maybe 15 odd minutes. So I'll pause this and let that work. Hopefully it comes out around the 60 to 65 million cell mark. So I'm kind of aiming for that because I know that I can open that back up in Fluent after it's done a simulation and do some post-processing. Okay, so fingers crossed. Now that's finished up there. That took about 20 minutes. As you see, I got what I expected, 64 million cells, which is manageable. And then the quality is very good too. The reason I get a poor mesh quality error is because it didn't get to 0.15, but that's fine. You can also make it a little bit better when you fix it up in Fluent. So that's the mesh. It's all done there, and you can have a study of it too if you want to have a look at it using your clip planes and stuff like that. So I'm going to just transfer this over to Fluent straight away. So I'll be back in a sec. Okay, now we're loaded up into Fluent. So yeah, we'll go through some of the stuff now that's all sorted. So the model that we're using, K Omega SST. I turn on curvature correction there as well. What I use then for my fluid, so air with that density and that viscosity. And now the boundary conditions, this is the most important part here. You need to get this right. So thankfully, the ground will still be moving at 22 in the X direction, and my wheels will remember the settings that I put on them for when they were in the sort of direct oncoming flow. That's because I duplicated this mesh block, this Fluent block. So they're all grand. So what will need fixing is the inlets. So these need to be defined like this. So you're going to define it through the components, and the X velocity will be the 22 from the speed you're moving at, and then this comes the crosswind in for the way I have my XY coordinate system laid out. My vehicle's there, so I want the wind to come from this inlet, so that's going to be going into the Z axis, so that's -5. I do like a 1% turbulent intensity. These won't matter too much whether you put that as 1 or 2%, as long as the inlet is a nice bit away from the model, which mine are. Yeah, 1%, -5 in the Z, and 22. So click apply on that. I usually click apply on it a few times just to make sure it's in. Inlet side will have the exact same. So you go to your components, you go 22 on the X, -5 on the Z, and then 1% there. A few clicks. So that's how you set up the inlet velocities. So just double check them then as well, because you don't want to make a mistake at this point. The outlets can wait as they are. They'll just gauge pressure of 0. They're all fine. And sky then I set as a symmetry. That's the roof. It's a nice bit away, 5H. Right, so the reference values. So this is where you'd put in your length of the vehicle. So make sure as well to keep the velocity at whatever it was during the oncoming. Remember, as I said in the PowerPoint presentation, not to set that to the new velocity magnitude, because it'll be hard compared to the direct oncoming flow simulation. So keep that at whatever it was for your yaw equals 0 flow. And viscosity, all that's good. So yeah, I'm going to just keep the reference length as 1 meter. You can put that in as 10. It's granted. So that's just the way I'm running with it. The area here is going to need to double. So you go down here, you do a projected area. Minimum feature down to that. Highlight all the wall. So I know this is going to be, so they shouldn't be down as walls. Don't know why they're there now as walls. Boundary conditions. Yeah, inlet main. Okay, they're not down as walls. Projected areas. Yeah, it's a weird one now. They should be under inlets and outlets for this here, but they're not for some weird reason. So I'll just click compute on those faces there. I'll give that a second, but that will come back as double whatever the reference value was in there. So this usually takes maybe a minute. I'll just pause it so you can see. Okay, that's finished there, and you can see I get this number back here, and that number is basically exactly what it was here. Double that. Because now we're running with a full vehicle and trailer rather than the kind of half body simulations we were running with before. So the area will have doubled, and so would the drag force. So the CD coefficients will match up quite well. Grand, so that's the reference values. I'll just, for my note, take a thing of the area. It's good to always note the area as well. Okay, so methods, yep, everything there as it is. I usually do run this with the Raichao momentum based. It is usually a bit more accurate and better, but there's very little in it. Just because I've done the initial simulations on distance based, I'm keeping everything with distance based. But in general, if you're starting off a new study, keep everything with the momentum based, but there's not much of a difference in it. Controls, relaxation factors, I'm keeping them as they are. So then the final step now here is to do with these report definitions, okay? So my lift is as is there, it's all in fairly okay. The original drag coefficient, that's fine as well, and then I do a drag parts as well. So that's a nice way so I can work out see how I click per zone there. So give that a go, doing a drag parts and a per zone with a drag coefficient in the X direction, and you'll see that it'll create a report for you with the individual drag components on each of them, so you can learn where most of your drag is coming from. For example, is it coming from the bumper and stuff like that, Okay, so they're standard, they've already in there, that's all good. As you can see, they were already highlighted, everything but the ground. So the new ones we need to create here are the side force coefficients, so we're going to click drag. And for the side force, we want it to be in the Z direction. Now, because I want to get I'm going to put this in as -1, because the force is going to be pushing this way against the vehicle. So to get a positive side force coefficient, I'm going to have minus Z direction. So if you spend a second thinking about that, it'll make sense. I don't want this to print to the console. I don't want it per zone. So that's basically everything there. And just give it a good name, like side drag. Okay, that's fine. Lovely. And then, so they're my 3 force coefficients. So now we're going to create the moment coefficients. The first one we'll create is the one around the Z there. So the Z is your pitch. So we'll just call it pitch. So you can see my Z axis there. You can do the right hand rule to curl around. You'll see it's pitch. And we're going to highlight all these. We'll turn off the ground. And set the moment center to 0, 0, 0. Now, you can obviously, if you want to think about it, it'd be nice to have that as your center of gravity if you knew it, but I'm leaving this as 0, 0. So that's, and I can move, you can think about it, you could translate your moment coefficients if you want to change the moment center by doing some maths on the values you get afterwards, but I'll leave that as 0, 0 for the minute. So the moment axis, yeah, so that says, so that's for pitch, for me, yeah. Don't print it to console, call pitch, moment, everything's good there. So my next here, so I'll create a moment now for roll, and roll will be around the x-axis. Okay, so I'm going to put that as 1, that is 0, and then put that in there, turn off the ground, don't print it to console, it's called roll, moment coefficient, all that looks good. Okay, so click OK on that. And then the final most important one is yaw. So same again. Now yaw will be around the y-axis for me, so it might be different for you depending on your XYZ. So just remembering how your car is sitting in there, take some time to decide on this and read up as well on the moment center and how stability will be affected depending on the size of these moments coefficients and stuff like that. So right, everything there seems good, so I'll click OK on that, and then you can click back into them to make sure everything's okay, but I'm sure everything's fine there now after I've gone through them. I have my monitors then down here. My monitors, I turn off, I go for a sort of deep convergence thing where I don't have any sort of benchmark for them to hit in which the simulation will run. So it's just going to run for 1,000 iterations, no matter what the residuals go down to. Other than that, that's everything. At this point here now, you wouldn't obviously be running something like this on your own computer. You're going to come up here and you're going to export it as a case, and then you're going to run it on a HPC supercomputer, which is what I'm going to do. And then I'm going to get the data file and the case file and load them back in here to Fluent and do some post-processing. So yeah, that's basically everything. There's nothing more to do here, and you'll get your results from the HPC. So that's how you perform a Crosswind study in Fluent. Hope it's useful, and thanks for watching. Cheers.